Hello and good morning. This is Sir Doms. Welcome grade 9 students, and today we will have a new topic all about electromagnetic spectrum. For our intention, competency, compare the relative wavelengths and frequencies of different types of electromagnetic waves, including radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma radiation. And for our objectives, at the end of the lesson, the students should be able to first explain the inverse relationship between wavelength and frequency. Second, arrange the 7 main regions of electromagnetic spectrum in sequential order based on increasing frequency. And lastly, recognize the importance of each waves on the spectrum. Think about it. What do these objects have in common? So as you can see from the picture, we have here a microwave oven, we have cell phone, we have satellite, and then we have remote and X-ray. So what is common to all these pictures? From our previous lesson, we learned all of this produce electromagnetic radiation. So all of those produce electromagnetic radiation, mostly unseen, but some we can see. But are all these electromagnetic radiation or EM waves the same? So today we are going to unlock the secrets of this invisible family of waves that rules our modern world. Are you ready? For our initial activity, we will have unlocking of difficulties. This is about the different parts of transverse waves. So we have here 4 choices. We have crest, trough, wavelength, and amplitude. First question, it is the highest point or peak of the wave. So the answer is, it's the crest. Second, it is the length of a single complete wave cycle. So the correct answer is wavelength. Third, the maximum distance the wave vibrates from its resting position. So the answer is amplitude. And lastly, it is the lowest point or valley of the wave. So the correct answer is trough. So the highest point is crest and the lowest is trough. And now we have here illustration of a transverse wave. So let's identify the different parts of a transverse wave. And so a while ago we learned that the highest point is the crest. And then the lowest point, number 2, is the trough. And number 3, it is the distance between the crest to another crest or trough to another trough. It's what we call wavelength. And then number 4, it is the height of the wave from the equilibrium. It is amplitude. And now for our learning experience, the title of the activity is Investigating Wavelength and Frequency. For our materials, we will use slinky toy and ribbon, meter stick, and timer. So the first part is how to measure the frequency. So when we say frequency, it is the number of wave that passes through a point per second. So first, stretch the slinky on the floor with one student holding each end. Second, one student creates transverse waves by moving one end up and down at a steady rhythm. Number 3, another student starts the stopwatch for 10 seconds. And then count the number of complete waves produced during those 10 seconds. So count one wave each time a crest is followed by the next crest or trough to trough. Next is to calculate the frequency. So we have a formula, F equals 1 over T. So task 1. Stretch the slinky on the floor. One student should hold each end firmly while another student creates the waves. Move one end of the slinky up and down slowly and gently to produce waves within 10 seconds. And then measure and record the wavelength and the frequency. So we are applying a gentle force in making this transverse wave. So answer key. So for our first task, the number of complete waves produced during those 10 seconds is 15 waves. Following our formula, F equals 15 over 10. So we divide that and so we get 1.5 Hertz. So the unit for frequency is Hertz. So it means that in every 1 second, the number of wave that passes through is 1.5. And as you can see, the wavelength is long. And now for task 2, move the slinky up and down quickly and continuously while keeping the slinky stretched to the same length. Measure and record the wavelength and the frequency within 10 seconds. So again, the only difference we will make is we will make quicker force. Quicker and stronger continuous force. So the number of complete waves produced during those 10 seconds is 25 waves. And so to get the frequency equals 25 over 10. Means that in 10 seconds, the number of waves that pass through is 25. To get the frequency, we will just simply divide them. So 25 divided by 10 equals 2.5 Hertz. So it means that in every 1 second, the number of waves that passes through a point is 2.5 waves. And then by measuring the wavelength, so as you can see, compared to a while ago, the wavelength is shorter. So that is the wavelength in our slinky. So let's compare the wavelength of the task 1 and task 2. So as you can see, in the first task, the wavelength is long, and then in task 2, the wavelength is shorter. So guide questions. Let's answer this table. Let us differentiate the two waves in task 1, where we use a gentle wave, and for task 2, we use a quick wave. Let's compare them in terms of wavelength, frequency, and energy. For wavelength in task 1, it is longer. And then for task 2, the wavelength is shorter. For frequency, the task 1, where we have gentle wave, the frequency is lower. It's just 1.5 Hertz. And for task 2, the frequency is higher, 2.5 Hertz. And for energy that we use, for task 1, the energy is low. And for task 2, it is comparatively high. Another guide question, number 1. Which motion produce? For another guide questions, number 1. Which motion produced waves with a longer wavelength? Number 2. Which motion produced waves with a shorter wavelength? Number 3. Compare the frequency of the two waves. Number 4. How did increasing the frequency affect the wavelength? And now let's answer the question. Number 1. The wave with gentle force have longer wavelength. So when we apply gentle force, the wavelength is longer. Number 2. The wave with more force have shorter wavelength. So when we apply stronger force, the wavelength becomes shorter. Number 3. The wave with gentle force have lower frequency, while the more force have higher frequency. So from our activity, we learned that we apply low energy or gentle force, it has lower frequency. But if we apply more force, the result is higher frequency. Number 4, the relationship of frequency and wavelength is inverse. It means that when we increase the frequency, the wavelength becomes shorter, while when we decrease the frequency, the wavelength becomes longer. And now that activity is related to our topic today. It's called the electromagnetic spectrum. So the electromagnetic spectrum arranges waves based on their wavelength and frequency. So we learned from our activity the relationship of wavelength and frequency. The electromagnetic spectrum applies this concept. The 7 different regions of electromagnetic spectrums are as follow. First is the radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. So, as you can see, there is an illustration of the wavelengths of each electromagnetic wave. The one with the longest wavelength is radio wave, and the one with the smallest wavelength is gamma ray. Okay? So the middle part is the visible light. So they are arranged according to decreasing wavelength. Okay? So the radio has the largest wavelength and the gamma has the shortest wavelength. But from our activity, we learned that when the wavelength is long, it means that it has low frequency, and therefore gamma ray, which has the shortest wavelength, has the highest frequency. Also, we learned from our activity that when there is higher energy, there is higher frequency. So the wave with the highest energy is the gamma ray, and the wave with the lowest frequency is radio. Electromagnetic spectrum have different uses. In this illustration, we can see the different uses of electromagnetic waves. For example, in radio waves, they are used for radio communication. In microwaves, it is used in cooking in microwave oven. Infrared radiation is used in remote control. Visible light is the shortest band in the electromagnetic spectrum. So this is just a small region, but because of visible light, we can see. So it's very important. So visible light have different colors. Ultraviolet radiation is produced by the sun. And then X-rays, we use it in medical purposes. And gamma rays are used for radiotherapy. So the one with the longest wavelength is radio wave. It could be as long as a football field or as small as a ball. For microwave, the wavelength is lesser than 1 meter. And then for infrared radiation, the size is 1 meter to 1 millimeter. So mind you class, 1 millimeter is just the small line in the ruler. And then for visible light, the wavelength is 700 nanometer to 400 nanometer. So that's very small class. And then the ultraviolet radiation, its wavelength is 400 nanometer to 10 nanometer. And then for X-ray, the size of the wavelength is 10 nanometer to 0.01 nanometer. So mind you, it is the size of an atom. Next is gamma rays. The wavelength is just 0.01 nanometer. And then for frequency in hertz, the radio waves has a frequency of 3 times 10 raised to 8. And for microwave, the frequency is 3 times 10 raised to 8 to 3 times 10 raised to 11. That exponent, 8 and 11, those indicates the number of 0. So it means that it has very, very high frequency. And then for infrared radiation, the frequency is 3 times 10 raised to 11 to 4.3 times 10 raised to 14. So as we continue to gamma rays, the frequency increases. For visible light, its frequency is 4.3 times 10 raised to 14 to 7.5 times 10 raised to 14. Ultraviolet is 7.5 times 10 raised to 14 to 3 times 10 raised to 16. And then X-rays, the frequency is 3 times 10 raised to 16 to 3 times 10 raised to 19. And for gamma rays, its frequency is greater than 3 times 10 raised to 19. So the different sources of these electromagnetic spectrums are, so for radio waves, its sources are radio and TV broadcasting. For microwave, it's microwave ovens, and then for infrared radiation, it is used in heat lamps and thermal cameras. For visible light, its use is sunlight and light bulbs and LEDs. For ultraviolet radiation, sunlight, tanning lamps, and sterilization. For X-ray, it is used in medical X-rays, security scanners, and for gamma rays, it is used in cancer treatment and nuclear reactions. So let's have a short discussion of each electromagnetic spectrum. First is the radio waves. The wavelength is the longest, can be as big as football fields or buildings, and its frequency is the lowest. For the use of radio waves, it is used in broadcasting your favorite FM or AM radio stations and TV signals. And it is also used in two-way radio communication used by security guards. Next is microwaves. The wavelength is shorter than radio waves. It is measured in centimeters, and the frequency is slightly higher than the radio waves. So microwaves have many uses. It is used in heating food and carrying Wi-Fi or satellite phone signals. So the satellites in outer space is used for live broadcasting. And so our favorite Wi-Fi, and then it is also used as radar. Next is infrared. So the wavelength is shorter than microwaves. Its frequency is higher than microwaves. And the fact is, we can see it but we can feel it as heat. So the uses of infrared includes TV remote control, and then for thermal imaging cameras. So during pandemic, these thermal imaging cameras are widely used to determine people with fever. So when they have fever, they appear red. It means that they have high temperature, and it is also used in night vision goggles. Next is visible light. Its wavelength and frequency is right in the middle. So fun fact, this is the only part of the spectrum that human eyes can actually see. So the rest of the electromagnetic spectrum are invisible to our eyes. So visible light is used for our vision, for lighting. So it is used in our bulbs, LEDs. It is also used in photosynthesis. So visible light is very important, and our favorite photography. Next is ultraviolet rays. The wavelength is shorter than the visible light. The frequency is higher than the visible light. Fun fact, it carries enough energy to cause sunburns. So the uses of ultraviolet ray is that it is used in sterilizing medical equipment. It is also used in checking fake banknotes. So when you put the money or the banknotes under this UV, you can tell if it is fake or real. And in forensics, it is also used to locate traces of blood, of fluids, and fingerprints. Next is X-ray. The wavelength is super short, the size of atoms. The frequency is very high energy. It is ionizing. Fun fact, it can easily pass through skin and muscle but gets stopped by our dense bones. So that is why X-ray is used in medical purposes. Uses: it is used in airport security to tell the contents of your luggage. It is also used in medical imaging and for industrial inspection to check the quality of welding. And finally, gamma rays. The wavelength is the shortest wavelength in the whole universe. Its frequency is the highest frequency and it also has the highest energy. In fact, it is released by nuclear reactions and stars. What are the uses of gamma rays? It is used in cancer treatment or what we call radiotherapy to destroy bad cells, and it is also used in sterilization. For our application, we have a situation. A family uses different technologies every day. First, father listens to the radio. Mother heats food in the microwave oven. Sister uses a TV remote. And brother gets an X-ray after injuring his arm. So, guide questions. Number 1, which electromagnetic wave does the radio use? Number 2, what electromagnetic wave heats food? Number 3, what wave is used in the TV remote? Number 4, which electromagnetic wave helps doctors examine broken bones? And number 5, which among these has the highest frequency? Let's check your answers. Number 1, the correct answer is radio wave. So the father uses radio waves. Number 2, the correct answer is microwaves. So in heating your foods, your mom uses microwaves. And then, used in remotes, it's infrared. Number 4, your brother that has an injury used X-rays. The one with the highest frequency in that situation is X-ray because your brother got an injury and so he went to the hospital for X-ray. And now let's wrap up our learnings. Electromagnetic waves differ in their wavelength and frequency. Next, as wavelength decreases, frequency increases. They are inversely proportional. Next, radio waves have the longest wavelength and the lowest frequency. Gamma rays, on the other hand, have the shortest wavelength and the highest frequency. Next, visible light is the shortest region in the electromagnetic spectrum and it enables us to see. Next, different electromagnetic waves have different uses that improve our daily lives. As you move from radio waves to gamma rays, wavelength decreases while frequency and energy increase. And now get your notebooks and your pen. It's time for assessment. Number 1. Which electromagnetic wave has the longest wavelength? A. Radio waves, B. X-rays, C. Gamma rays, or D. Ultraviolet rays. Number 2. Which electromagnetic wave has the highest frequency? A. Infrared, B. Gamma rays, C. Radio waves, or D. Visible light. Number 3. Which electromagnetic wave can be detected by the human eye? A. Infrared, B. Ultraviolet rays, C. Visible light, or D. Microwaves. Number 4. As wavelength decreases, frequency blank. A decreases, B disappears, C increases, or D remains the same. Number 5. Which electromagnetic wave is used to check fake banknotes? A. Radio waves, B. Infrared, C. Microwaves, or D. Ultraviolet rays. Now let's check your answers. Number 1, the correct answer is A. Radio waves have the longest wavelength and the lowest frequency. Second, the correct answer is B. Gamma rays have the highest frequency and carry the most energy. Number 3, the correct answer is C. Visible light is the only part of the electromagnetic spectrum that the human eye can detect. Number 4, it's C. Wavelength and frequency are inversely proportional. When wavelength decreases, frequency increases. And number 5, the correct answer is D. Ultraviolet rays are used to check fake banknotes by exposing hidden fluorescent features. How did you do, class? Did you get a perfect score? Comment down below if you get a perfect score and then comment which school are you from. And now for ways forward. At home, list at least 5 devices or technologies you use every day. Identify the type of electromagnetic wave each one uses and explain how it helps you in your daily life. See you next lesson! Remember, Like the electromagnetic spectrum, every person has unique strengths. Though we differ in many ways, each of us has a special purpose that can brighten the world. Thank you for your support. Please like and subscribe to Sir Dom's blog. Goodbye!